import geometry into Apex, go to File, Import, Import Geometry. Click on Browse. Select the file you want to import. Click on Open. Ensure the Clean on Import checkbox is checked. Under Model Contents and Organization, you can pick what you want to import. For this example, we're going to import everything. And then you just click Import. As you see there, your file has imported. In order to mesh your solid body, go to Meshing, Solid Mesh, choose an appropriate element size, and click on the body you want to mesh. You will see that the meshing occurs automatically due to the auto execute mode being selected. Now you can just close your meshing panel. To assign a material, go to Materials, click Create Material, create a material name, define its elastic properties. What you see here is that I entered 2E11, which is typical for pascals, but the default units in this case is in megapascals, so I can just adjust the unit and the quantity will be updated automatically. Enter the Poisson's ratio. And now we can add the mass properties as well by going to Constitutive Model, click on the plus entry, add the mass option, click OK, and here we can add the mass. Once again, enter SI units if you want to, press enter and correct the units to match the SI units, and you will see that the units have been updated correctly. Next, you can click on Assign Material. Click on the body you want to assign the material to, and it is done. To create your interface points for atoms, you can go to Attribution Panel, Interface, and this brings up the interface menu you see here. In this menu, you must change the application method to apply interface at remote location. Now we can select the faces where we want to apply the interface point. First we can select faces, edges, vertices or points, or nodes actually. If we select faces, we can just click on the faces where we want the interface points. Because auto execute is on, as you can see over there, Apex automatically creates the interface points at the center of the selected faces. If it's cylinders, it conveniently creates it at the center of the cylinder. If you want more control over where the interface points is, you can deselect the auto select tool, auto execute tool, and then you can just select the face where you want to apply the interface points to, and press middle mouse button. This brings up the ability to change the location of your interface point. Let's move it up by a couple of millimeters. Press enter. As well as, if you press middle mouse button, the orientation of your interface point. You can either do it by dragging each one of these axes or by entering an Euler angle in this menu over here. For now, we're just going to keep the orientation as it is and press middle mouse button to complete our interface point. Another option that may arise is if you want to apply an interface over multiple surfaces. All you have to do then is hold the control button and select all the faces where you want the interface to connect to and press middle mouse button. As you can see here, the interface location has defaulted to the center of the first surface that was picked. This can easily be remedied by just picking the automatically created point between the center of the two faces, as we see there. Now by pressing middle mouse button once to fix the location, and then middle mouse button again to fix the orientation, our interface point is created. And that's how you create interfaces in Apex for atoms. let's say for instance you want to modify an interface point in Apex for Atoms. All you have to do is go to the part tree, open the part where the interfaces are, go to interfaces, and here you will see all your interfaces listed. Go to the interface that you want to manipulate and double click it. You'll see its menu opens up over here where the face is listed to which it is connected. If you want to change that face, you can do it here. Or if we're happy with the face, click middle mouse button. It will bring you to the location. Now for this location, we can either use the triads again to move it, or if we select the center of the triad, we can move it around either by dragging it or by selecting certain geometric features. In this case, I selected the face and I want to place it at the center of that face. Middle mouse button fixes my location, and then let's say we want to change the orientation by inputting an Euler angle. We can just clear the current entry in here. You see there's the current Euler angles, and let's say I want to change the first angle, Z angle, to 90 degrees. Press enter and middle mouse button, and then my interface is modified. I can just close this window, and that is how you modify an interface point in Apex for Atoms. The final step is to write out the MNF file for Atoms from Apex. First thing you need to do is see if the analysis interface panel is visible. If it's not, you can expand it by just clicking here. Now you can see your analysis interface panel. Over here in the mechanical system, it says not specified. That is because you haven't told Apex yet what part you want to analyze. You can do that by going to your part in the part tree, right-clicking it, and say place in analysis scene. This takes you immediately to the analysis readiness tab. What you will see here is that there's a couple of requirements that are not met, and that is because it assumes you want to do a static analysis. However, for an MNF file, we want to do a modal analysis. So we can just change it to normal mode, and you can see those errors are no longer there. What we can do now is we can say generate a simulation scenario for us, and that creates the mode scenario that we're going to use to write out the MNF file. Now, MNF file is not automatically generated by Apex. In order to request it, you need to go to Output Requests, right-click, Properties, or just double-click it. Go to the MNF Export tab and say Flex Body Output. Over here, under Browse, you can choose where you want to save your MNF file. Over here, you can choose what mass invariant you want to use. And for this one, we're just using partial mass invariance. And now you can check these checkboxes if you want to do grid point stresses or grid point strains as well for the MNF file. Once you've done with this, your analysis is ready to solve, and you can click this running man over here to solve the analysis. Now you can see our analysis has solved completely. Just waiting for the final files to be completed. And the analysis is done. Now we can go view the results in the post processor, or if you're happy that the results are correct and you're satisfied, you can just go and use your MNF file. Let's quickly go have a look at the results. If we click on the output, on the post processor button over here, take us to the Apex post-processor interface, where we can view for the modes that we've solved. So if you can click any of these bars, they represent the different modes. So as you can see, there's mode 3 and mode 4. Let's have a look at mode 4. We can apply a fringe plot to it, and we can animate it by just pressing the play button. If you want to go back to the normal Apex interface, you can exit your post-processing interface by pressing this button over here. And that brings us back to the normal Apex interface. The default output settings for Apex only gives 10 output modes. However, if you want more output modes, you can go to Simulation Settings, double click it, or say right click in Properties, and then over here you can choose the number of modes which you want to solve for, or the frequency range or limits which you want to solve in between. And that is how we solve for an MNF file for normal modes in Apex.